Okay, hello everybody. This is a lightning talk, so I'm going to go pretty quickly. It's called Price Feed Oracles, and I'm going to show a little bit about how we plan on using zero knowledge for oracles at MakerDAO, and what we're currently using, which is probably not as good as what we could be doing. So, quick introduction. My name is Mariano Conti. I'm the head of oracles at Maker. And just a disclaimer, I have zero knowledge about zero knowledge. You probably heard that one before. So I'm here mostly to learn, watching all the sessions and maybe catching up with some of you. And that's the disclaimer, right? So I'm going to talk a little bit about what our oracles are right now, version 1. They're essentially just smart contracts that store for each asset, like ETH or MKR or eventually DIGIX, they store only price in USD, for example, and the timestamp. That's basically all they do. And if you get like 10 or 15 of these controlled by different parties, you essentially have a decentralized Oracle network, and you plug a medianizer contract, which reads from all of this and calculates a median on these prices. Then you have a real decentralized price feed Oracle, and this is what we use to control the prices on the DAI credit system. And there are several problems with this. The main one is that every single Oracle, whenever it updates its price, they need to send a transaction. So with the volatility we have of different assets, this can often mean several transactions per day, sometimes per hour, sometimes even every couple of minutes, right? And the more oracles you get, assuming they increase security by decentralizing, they also have like a huge gas cost. So we're moving to a version 2, which use signed messages. So every single oracle has just public-private key, they're an Ethereum address. They sign messages with the price and timestamp. They're distributed via Scuttlebutt, which is really amazing, and looking forward to the Scuttlebutt talk later. They are aggregated off-chain. We can move some of that computation off-chain by maybe sorting by price. We verify it on-chain, and this means that we get only one transaction per update, comprising all the different oracles, say 10, 15, 20 or more. This lowers gas costs, and we still keep it decentralized as long as you have access to the Scuttlebutt network to get all the messages. So assuming we have an oracle, let's say that's an Ethereum address, let's say the price is 260, I wrote this morning, so it's probably lower now. Timestamp, you hash both of those and you get a 32-byte hash. You sign that with the private key. You get a hash signed message. And this is just like a quick Solidity smart contract. I removed stuff for brevity, but essentially you have to go through every single message. You have to validate, do an easy recover to validate that the data you get from each of the oracles belong to a whitelisted address. You require that the age is newer than the previous one. You check that the values are ordered, and if they are, then you just get the median, right? If there were an even number of values, you just grab the middle two and do an average. If it was an odd number of values, you just grab the one in the middle, you write it, and you're done. So I want to talk a little bit about what we want to do in 2019 for version 3. So what if we could move even more of that computation off-chain? Could we use aggregate signatures maybe, something like BLS? We're looking at how Ethereum is, what they're doing to solve the proof of stake problem. I know they mentioned having thousands of signers verifying data. Problem is, we cannot afford a 24-hour challenge period, right? We need data that's as real time as it gets. If the price of Ether is crashing at 10% per hour, we cannot allow that to, we cannot have challenge period of 24 hours where maybe the price is going to be totally different from what the system has, and that would allow you to maybe borrow DAI at a ridiculous price. Can we do a Merkle tree representation of n number of messages? Can we just check the root for that? Is that even really possible? These are all just questions that I've been asking myself. Here's a hypothetical. How about we have 5 oracles? They each sign a message. There we can see in the table that they're sorted by price. Let's say we have the prices, the timestamps, the signed messages. Can we grab all of these into one single signature and verify it on-chain that you want the correct median of the price? I have no idea, but I'm hoping that I can answer this question soon. And a couple of more. Can we mask Oracle addresses? This would make it very secure for the Oracle signers. Can we only know that an address is in a whitelist? Can we even hide that whitelist? What is the cheapest way we can prove on-chain that the computation even happened? Can we use something like Intel SGX? Some of the other methods that people have brought up here. Do we know that we're using the correct data? We also have to assume that everything is, of course, signed by a whitelisted Oracle, right? So, like I said, this and other challenges, we're going to be working on them in 2019, and we're looking for collaborators to help us with the challenge. So, if anybody wants to tackle this alongside us, please feel free to message me. And I will see you around in Berlin this week. So, thank you.
Who wants to go next? I don't know. I think we had an order, but I don't know. Where's Cory? Do you want to go, Cory? You just mentioned Scuttlebutt, so that might be a good follow-up. You have slides, yeah? Yes. Cool. I forget which one we have for you. Nice. It's this guy, yeah? It's this guy.
This one, yeah.
Yeah.
But okay, if you have one, then great.
Cool. I have to go run and deal with some stuff out there,
I can
so
take
I'm going
this.
to be back in 5.
Yeah.
Cool.
Oh no. Sorry, bear with me. 1 sec. Somewhere there's a full screen. How's everyone doing? Do people know about Scuttlebutt? Can I get like a hand of people who have like heard of the project and kind of have a rough idea of what it is? Cool. How many people have downloaded Patchwork and actually like used it ever? Couple? Nice. All right. So my name's Cory. I am an independent researcher and spent a lot of time also working in the music industry, but kind of half of my time is meandering around the blockchain space. Done a number of things kind of over the years. sometimes in the blockchain and music kind of ecosystem, but more recently, I've been getting involved with this project called Scuttlebutt, doing a process research project of my own there. And here I'm going to kind of give you an overview of just sort of what the project is, very briefly, and then some of the interesting ways that I'm kind of noticing this community think about governance and think about how they're making decisions, how they're allocating funds, how they're organizing and collaborating together. So in some ways that I think actually the rest of the blockchain ecosystem can actually take some interesting learnings from. So to start off, let's look at Scuttlebutt and kind of ask ourselves like what this thing is before we go into some of the ways that they're operating. And to do that and to motivate that, I kind of want to pose this first question of like, why is it that we actually even talk about consensus within the decentralized ecosystem that we're talking about today? And one way of kind of framing it is that we talk about consensus, or we need consensus in our systems in as much as we need multiple identities to validate transactions. So the converse of that is, if all you really need is to verify that someone said something, that they like made a claim, and you actually don't need other people to check or to do any kind of double spending prevention, there's really no need for consensus in that way. And what I'm going to show you in a bit is how like social networks actually have this property where that isn't a requirement. So in the blockchain ecosystem, most of what we're talking about are identities and identities owning things. So there's a lot of asset transfer, be that coins, be that NFTs. And if you look at what social networks are, they're really much more about identities and identities saying things. And to validate that someone said something, all you need is a signature and a kind of proof or some sort of understanding of who they are. And so Scuttlebutt is kind of a protocol, but then it also has some applications that run on top of it, mostly operating within the social network space. And at the protocol level, what it is it's a personal chain. So every kind of user or device would have its own chain of cryptographically signed messages. Then there's a social network that kind of acts as a network topology. So you can imagine a social graph, but as these identities are tied to devices, the social graph actually can kind of represent a network topology. And then there's a gossip protocol that kind of motivates and allows for the message propagation throughout the network. So that's how content actually travels throughout the Scuttlebutt network. So in our case, where we can start and look at kind of the use case of a social network, here we have Dominic Tarr, who's the founder of Scuttlebutt. He lives on a sailboat in New Zealand, and sometimes Dominic wants to chat with his buddy Substack, who is also sometimes spending some time on Scuttlebutt. The two of them have their apps, they're downloaded on their computers, yet because they're kind of in these the internet isn't, connectivity isn't so great when you're living on a sailboat or when you're on a solar farm in Hawaii where Substack lives. So they're using Scuttlebutt as a means of communication that kind of is really effective for these sort of low bandwidth scenarios. And one of the things that I'm not going to talk about in detail as much, but it's a really interesting property of Scuttlebutt, is how it's offline first. So using the app, reading it, is all stuff that's happening on your app, directly on your computer. No network activity there, but the kind of synchronization and any of the data catching that it's happening is going on in the background. So what's going on here again is we have Dominic and Substack talking to each other. They're each kind of broadcasting that they follow each other. And then if they're in the same local area network, or you can also use these things called pub servers to communicate with each other, that's how they can kind of broadcast that they're interested in each other's data, and with that can exchange messages. And so in this kind of world of Scuttlebutt, you kind of have this model where everyone's getting a chain of cryptographically signed transactions instead of one unified blockchain that we're all supposed to kind of agree on the state of. So here's a little preview of what the app looks like. There's a bunch of active channels. There are pubs that you can connect to, and people are basically posting. Essentially, it's like a Twitter where instead of 128 byte characters, there's markdown posts of a couple thousand words. And so as I mentioned before, you also have pubs, which essentially act as these self-hosted servers for individuals or communities. These pubs replicate your feeds and your friends' feeds. Essentially, they replicate the feeds of anyone who that pub follows. And so they act as an always-on user. That's essentially another node in this social graph. And so now we're going to shift a little bit to talk about governance and the way that within this ecosystem, people are thinking about how they want to operate and how they want to contribute to the development of this protocol, of this project. And so, on the contrary, you can kind of look at how people are thinking about governance in the rest of the blockchain space. And there's a lot of talk of on-chain or off-chain. But since there's no singular blockchain here, that's not even really on the table. We really have to be thinking from the core, what does it mean for us to be communicating with each other? What does it mean for us to be in a decentralized organization where it's literally just a bunch of open source contributors and community members on the internet? How do we actually coordinate to solve problems together? So within Scuttlebutt, there are kind of two main principles that I want to sort of hammer home today that I've noticed in the research that I'm doing, which is this idea of one, soft governance, and two, experimental funding schemes. And so soft governance is a term that you can see in a lot of talk around project management research. And some examples of that is within models of soft governance, you can have acting as a participatory leader who involves team members in strategic as well as tactical aspects of the project, promoting cooperation rather than competition among team members, installing governance mechanisms that are explicitly flexible yet formal. So that third one maybe sounds a little bit like some of the things we talk about in on-chain governance, but as you see on the right, these kind of principles for hard governance, having formal bureaucratic procedures, roles and responsibilities being clearly delineated, these are all things that we always think about in the decentralized space when we're thinking about governance, but all too often, we forget about some of the more softer kind of interpersonal aspects of what it means to do human coordination. And so on Scuttlebutt, not only do you have people actively interested in this stuff, but some of the people who are quite prolific in this space and in the theorizing around decentralized organization from a very kind of soft human perspective, they're active on this community. So Richard Bartlett has written a book that's an EPUB, which you can grab and download, that talks a lot about these ideas from intentionally producing counterculture, systematically distributing care labor, talking about power as like an explicit kind of part of the way that you organize and kind of make decisions. And with people like him on the network, we also have active developers in the community like Andre Staltz making explicit posts and talking about what it means for us to have principles within the context of this project. And the last thing that I'm going to mention is some of the experimental funding schemes that are at play within Scuttlebutt. There are kind of three main ones that we've sort of seen happen over the past maybe 6 to 12 months this year. The first one is a more formal program called SSBC Grants. This was initiated by a large sum of money that we actually received, the organization of Scuttlebutt received from Definity as a grant. And with that money, there was basically a GitHub repo that was initiated, a grant procedure initiated that explicitly said, we're going to have up to 4 grants each month. We're going to give $5K USD for each grant. We're going to rotate all the administrative roles, and all discussions are going to happen directly on Scuttlebutt. So with that, you kind of had the founder, Dominic, who kind of proposed this, initiating and kind of deliberating and giving out power to the rest of the community to and to charge them essentially with distributing these funds. And so some of the other ones around mobile SSB quests, this was a grant that, I'll wrap this up. This was a grant that Andre Staltz received specifically for his work that he's doing on a mobile application. And with that, he basically came up with a bunch of larger scale bounties that he wanted to issue. And SSB Chure is a smaller experiment around tipping that people are exploring with. And so with that, I kind of want to throw out this idea that we can think of governance as more or less mechanisms for distributing funds. Maybe that's not all that governance does, but that's certainly a core part of it. And within the decentralized ecosystem, I see a lot of talk about developer bounties. I see a lot of talk about larger scale grant programs. But what I don't see as much is decentralized coordination processes for allocating funds that start at the very small and experimental, and as they succeed, grow into kind of larger scale and larger scope. So this is an overview of the stuff happening in this world, and I'm curious to hear how other projects are kind of thinking about these problems as well. Thanks.
Thank you. All right, we're going to have Rachel come up next with Summa. Yeah. Hi, guys. I'm the new MC, Hudson. Anna had to go. Welcome, Rachel. Give her a hand. My jet lag. Ugh.
Hi, I don't have a presentation prepared, sorry. But I work at Summa, I'm a backend dev there. And one thing I really like about Summa is that we're basically taking the current infrastructure in the space and we're just building off of what's there and what currently works. We're specifically targeting ways to manage and hedge risk for financial, for crypto holders. And so we do this by building a set of financial tools, and they're completely trustless, which means there's no third party, there's no oracle. It's just between two parties, and they can trust each other via secret sharing. And some of the tools we built are, like, we have options, we've got hash rate derivatives, futures, forwards. We have a whole, like, plethora of prototypes. And essentially, we try to take away a lot of the risk in holding a lot of crypto by being able to enter into these contracts. And if, for example, like a buyer and a rider will enter into an option, right? And a buyer will initiate like a secret, and then in order to gain the rider's funds, the buyer has to reveal that secret. The rider can verify that the buyer is providing the accurate secret because the rider knows the hash of the buyer's secret. And then once the buyer reveals that secret, then the rider can go to the buyer's chain and get the buyer's funds. So it's kind of like a higher level idea of what's going on. We can enter into these contracts on Bitcoin chains, Bitcoin-like chains, and we can also trade between like Bitcoin and Ethereum and any number of like ERC20 tokens as well, which I think is pretty cool, and like also any mixture. And one problem is liquidity, because if you enter into these contracts, right, like you lock up your funds, and like nobody wants to do that. No one wants to lock up a bunch of their Ethereum and then just be sitting there for like 6 months. So in order to do that, we have actually like tokenized a lot of these contracts. So we like tokenize options, and then the rider can take the new ERC20 tokens and enter into other contracts and like other options with these tokens. So you have like tokens on tokens on tokens, and it's pretty cool. And the idea is you basically have like, you can do theoretically like infinity options, even though James says you can't do infinity options, but maybe you can. And then you can kind of like build out a marketplace based on that. So that's what we do at Summa. Thank you.
All right, thank you, Rachel. All right, and finally, we have Julian? Yeah. Yes, from Radicle. Give him a hand. Is that the wrong one?
Yeah, but you see this.
Let's see if it doesn't work in a second. Oh, there we go. There you go.
Thank you. Hi. I'm Julian. I work for Monatic on the project Open Source Coin. And I'm going to be talking about Radicle, the language we've developed. And this is the Radicle REPL. So Ethereum built on Bitcoin by making the language in the blockchain general purpose. And this, as we all know, enabled a large array of smart contracts and a wider array of applications. But the result is always, as with Bitcoin, one very large program which runs everything and which every full node runs. Now, one possible solution that we've been talking a lot about is snarks that sort of solve some of these problems. But I want to talk first about specifically the open source coin case and see how there's another possible solution and how we came up with the design for Radicle. Now, open source coin aims to provide an incentivization mechanism for open source development, as well as a decentralized platform for open source collaboration. Now, I'm not going to talk about the first one here, even though it's really cool, because Eleftherios Diakomichalis is giving a talk tomorrow that you can attend, and because it's not my area. But I will talk about the second one. And in the second one, you can think decentralized GitHub. Now think of all the information that GitHub stores and processes and makes available. Now there are tens of millions of users, tens of millions of, almost 100 million repos. Each repo has a long list of commits and a number of issues. Each issue has comments, and the PR as well has sort of a number of commits, and then discussions on those, and then many more things besides those. Now, two things become apparent when you consider this. First, that it'd be insane to sort of ask everyone, if you're creating a decentralized version of this, to store all of this data and process all of this data. And second, the data segments across semantic boundaries. So you have threads, sort of, with specific meanings. Now, this meaning, the semantics, determine what the elements in a thread are, for instance, comments, and how they relate to other data, being about a particular issue on a particular repository. They also determine what content is allowed. So if you're thinking of all the commits, the commit history as a thread, then only valid patches are allowed. Anything else is not allowed. And also they determine, so the semantics of the chain also determines who's allowed to contribute or change that content. So only contributors or maintainers are allowed to make a commit on master. Now, at OSC, at Open Source Coin, we decided to sort of do justice to this semantic boundaries. And so this led us to multiple chains. I know this idea that exists elsewhere as well. But each chain, additionally, can very easily be given its own semantics, and this is where Radicle comes in. So if in Ethereum you can program in a chain, in Radicle you can program the chain itself. So as a very simple example, I'll have to put the microphone down so I can code. So as a very simple example.
Gotcha.
Thank you so much. As a very simple example, I'll enter a chain. So I'm now in a new chain. And here, so Radicle is basically a Lisp with a few other things. So, prefix, parenthesize expressions. And if I run this, I get 5 as I might expect. But then, additionally, I can define eval, the semantics of the chain, to be a function that takes an expression and always returns true. Now, if I run the same thing, it returns true. So I've changed the semantics in a very, very silly way of a chain. And now if I try to do anything else in this chain, it won't work because everything is not evaluated, instead it just returns true. So I'm going to quit this chain. Thanks. I might need you again in a moment.
No problem.
So as you might have noticed, the process of changing the semantics of the chain is part of the chain itself. Consensus, the underlying consensus, takes care of ensuring that we agree on the semantics. Now, you've probably wished that some code that GitHub had some feature X or Y, and you probably didn't get your wish, or you had to wait very long to get that wish. By decentralizing a service like GitHub, we gain the right to collectively define what the service is, rather than GitHub alone having that right. But with a language like Radicle, we're trying to give the means to do so. As an example, Radicle has a base library, Prelude, and you're probably familiar with this pattern where if you open an issue about bug report, you better have a reproducible test case to help the maintainers. If you're a maintainer, you sort of expect people to do that, otherwise you're pissed off. But there's no real way of enforcing that besides having on GitHub, besides having some sort of like text that suggests that you do so. Well, for us in the Radicle Prelude, a failing test case is basically some bit of Radicle code that, if you run it, fails by throwing an exception or by returning false. So when you create an issue, I can create an issue chain. Sorry, can I have you again?
Got about 1 minute, 2 minutes.
Yeah, okay. So I can create an issue chain. So again, I'll enter a new chain. And here I can define eval to be a function that I've already defined before for simplicity. And now if I try doing simple operations I'll get an error. The operation has to be one of new issues or list issues. And if I list issues, there's nothing there. But if I try creating an issue, I need the author, the title, a description, and a failing test case. So zk0x02 does not fail. Thank you. So the test is not failing, so if I list issues again, it's not there. Whereas if I make a failing test case equals 1, and then I list issues, I get the issue there. So in about 30 lines of code that you didn't see, I've managed to define my own issue system very quickly in a new chain. Now this is, thank you. Now this is just the tiniest example of Radicle. I don't have much time to go into more details on how this is distributed and network and whatnot. But on Friday, James, Hayden, and I, James is over there, will be talking about Radicle in a much longer setting for an hour. It's listed. It's on Friday at 6 p.m. and it's listed in the calendar. Again, as I mentioned, sorry. As I mentioned, I think I haven't. Yeah. Ellie is also giving a talk tomorrow at Decentral about the rest of the platform, sort of the incentivization scheme. There's a website with a simple REPL that's been compiled to JavaScript, free node, we use this over there, and email. Thank you.